My name is Henry. I am a programmer. I'm also a mentor at Angular Kenya. And in terms of where I work at Microsoft. I am part of the search core team. So anything that has to do with search, I'm kind of involved in one way or another. So today's session, much like Wayne has said, it's going to be a lot more of a discussion than me telling you things and you simply accepting them to be truths. Some of the principles and guidelines that I'm going to talk about, we also employ in my team. Some come from personal experiences. Before I begin, I think one of the things that I have noticed over time is that we can get a bit too hung up in frameworks and start thinking in that framework too much, and we forget the underlying language that the framework is built on. So this is to bring us back to first principles. And hopefully, as we have the discussion, we can agree on some things or agree on everything. But I want it to be more of us actually having a discussion. And so when I go through like the first point, and I go through the explanation from how I understand it, I'd like someone to chime in either with questions or additional points. Cool. I hope you guys can see my screen. Decided to use Markdown as opposed to PowerPoint. Yeah. Cool. So these are what I would consider the general guiding principles for TypeScript. Writing good TypeScript and leveraging on the POC TypeScript. The list is not exhaustive, otherwise we'd be sitting here the whole night. Because 10 usually looks like a good number, I ended up having only 10. So we'll begin with the first one. Also something is, it's going to be theoretical unless we have to move to code to actually explain some concepts, but a lot more of it is going to be theoretical and discussions. So the first use strong type safety. The purpose of TypeScript being a statically typed language is that you're able to catch bugs at compile time rather than at runtime. And TypeScript is able to do this because it can do static type checking as you code. The beauty of ensuring that you have a strongly typed language is you can enforce consistency and invariance in your code. For example, if each entity type in some data model needs to have a corresponding entity parser, the system can enforce that invariant, right? And I gave an example here where we have a type which is a union. So the type can either be a file, a person, or an email. And then we implement another type called a parser, and a parser takes in the utility type record. Part of what it takes is the type. It has returns an entity. So if we are constructing a variable, an object, which is supposed to be the actual parser, and it is of type parsers, then in our given example, we're actually going to have a compile time error. And the reason for that is because the type expects that the parser should have a person included as well. So in the above example, the type system is enforcing that parser's object must have an entry for each of the type. And in our case, we don't have an entry for person. And that before you even run your code, it will actually give you a compile error, a compile time error when you have a using VS Code or something. To get the full benefit of TypeScript, when you're working with like strong type safety, it's important for you to understand two major concepts. The first one is narrowing and type guards, and the second one is creating types from types. And something like narrowing and type guards will part of what we have at the general coding principles. We have something called discriminated unions, and that's, I guess, to a large degree what narrowing and type guards involve. But if you're looking at creating types from types, So for example, in our example above, the type parsers has been created or has been composed using the type entity type from above. So we are sort of creating different or unique types other than what is typically there in a language. So we have like the primitives, and then we have objects, so array functions and whatnot. But with TypeScript, you can sort of compose and structure or model your data so that you end up having other types that are typically not represented in the language, like JavaScript. And it's important for you to understand concepts like generics, especially generics. I think that's the most important thing. And like interfaces, extending interfaces, and types, adding onto types. The most important rule I would say is, as much as possible, you avoid using the type any and doing any sort of type assertion. So type assertion is when you do that as thing. So if you have file as an object or something, like you have that statement as, meaning you're forcing that type to correspond to a type that it naturally does not fit into. And in order for you to enforce this, I think the best thing you can do is make use of the TS config. So the TS config, you can actually enforce minimizing the use of any. I don't think you can completely get rid of using any in your code. And you can also minimize the use of type assertions. Now, before we go on to point number 2, I'm hoping that there are thoughts, questions, disagreements on point number 1. And so I'll actually just pause there for a minute and let someone chime in.
I have a question. Can you hear me?
Go ahead. Yes.
So I think I use type assertions a lot. So I'd really like to understand why. I get why type any is not good to use, but could you explain why type assertions are not good to use?
And I'm just going to open the MD part so that at least I can write some things. Or let's create a file here. We'll call it learning.ts. So let's assume we have a type. Let's create an interface here. And let's call it student. And what that interface has is like a name, which is string, maybe an age, which is of type number. Now, assuming you declare a variable Drew, and Drew is a student, right? There are instances where when you declare this variable, let's assume you give it a property name, and I say Henry, and then age, instead of the whole giving it as an age in number, I say 27 as a string, and then I cast this as a student. Let's say I do unknown, and then I cast this as a student. So in this regard, you can see we are forcing Drew to take the shape of student, and we are losing the power of the whole idea around catching those compile time errors, because you can actually force a type assertion, and you've seen I've casted it to unknown, and then I've casted it to student, and this results a lot, especially when someone tries to do typecasting and then they get these errors. It's very easy to bypass this error by simply casting to unknown or any first. But if you were to begin by, first of all, identifying Henry as a student, then it gives us a very clear error around where in our code base we are breaking that interface. If that makes any sense. So it's easy to bypass type assertions, but it's not easy to bypass if you've identified the actual structure of what it is. Does that make sense? I don't know who asked the question because I can't see the screen.
Yeah, it does make sense. It
I'm
does make
hoping they
sense.
can respond.
It does make sense.
Cool. Any other question or comment? Right, so we can move on to the second one. And both of these, like type assertions and any, you can add in your TS config and just model it so that those rules are captured. Then there's the second one, which is use discriminated unions, especially when modeling heterogeneous data. So I guess the first thing is to understand that in the true nature of what discriminated unions are, TypeScript doesn't actually have discriminated unions. What it does have are just unions, but there's a way you can sort of model your unions so that they behave like they're discriminated. And the idea around discriminated unions is that they help the system understand how different the different I guess let's say objects, because that's what we have in the example. If you look at the example where we are defining the type entity, we have an entity type called email, which has a subject. We have an entity type called file, which has a name, and we have an entity type called person, which has a string, which is a string. So it's very clear that while all of these are entities, they take different shapes. And yes, the fact that they do have one type which is common, which is the entity type, that's what makes it a discriminated union, right? Because that's the discriminator, the entity type. You can access the entity type if we were to declare a variable of type entity. The one thing that you can access right off the bat without you doing any sort of discrimination is the entity type. And you can use the entity type to know whether or not your object has a subject or it has a name. So this is kind of important because when you're looking at the code, it helps you make the right assumptions. You don't assume that every entity has a subject, and you don't assume that every entity has a name. So just using the same things. So assuming we come and we define that type here, and I define an entity of type entity. It has to have an entity type. Let's assume I give it an email. And a subject of
anaweza kwa nini
let's give my name.
Kwa nini usikule chakula uliekewa? Chakula uliekewa iko na shida gani?
Sorry about that. Continue.
No worry. So you can see the beauty of this is that the discrimination based on the discriminator, which is the entity type, lets us know what else we can access out of that object, right? So for example, if the entity is of type file, I cannot access subject. If the entity, if it's of type email, I cannot access name. And if it is of type file, I can access both name. If it is of type file and person, I can access in both areas, I can access the name. So as someone who's coding, it requires me, therefore, like the moment I know the entity type, it's easier for me to reason about what is contained within that object. And I don't make assumptions around what I can access and what I can't access. So if I had an object, I can't come and say entity.name unless I am sure that that object is either a file or a person. Yes. Is there a question around that? I'm really hoping someone disagrees with these things. Or at least says no, that I don't agree with that one, which is disagree. But yes, are there any questions around discriminated unions?
If anyone has a question, please, if anyone has a question, please feel free to ask, by the way. Okay. Thank you. I think we can move on.
No, I have a question.
Right.
On the first,
So this, yeah, go ahead. Thank you.
on the
Yeah.
first bit. So you're saying create types from types. By that, do you mean extending, or what exactly do you mean?
So one of the beauty of TypeScript is that you're able to create essentially new types, right? In JavaScript as a language, you don't have a type called entity type or a type called parser. It's a new shape. It's a new entity, not entity. It's a new quote unquote data type. So understanding how to leverage on TypeScript to be able to create new types is very important, right? So for example, we can create a type here called student, right? And student maybe has a name, which is a string. And then it has what? An age. I don't know why I'm stuck on this age thing. Then let's assume we create an interface. And our interface is called what? School. And school has students. And students are an array of students. So we can say array of student. You're seeing how we're able to like extend, have this one type and then have another type which relies on that type. And there's so many ways of doing this. One of them is that extending you're talking about. Another one is assuming you want to create another student, maybe a foreign student. The foreign student will be of type student, and then it will also have country, which is a string. So this whole idea of being able to find different ways of composing different data types is one of the most powerful things you can do and leverage in TypeScript. And you need to get good at it, right? You need to get good at generics. You need to get good at composing types. You need to get good at extending interfaces. You need to get good at using things like record, partial. They're called utility types. You really have to get good at that if you want to leverage on the power that TypeScript has, and not just creating interfaces all the time, right? Because we can, for example, let's assume student, what other thing can a school have? Teachers, and we'll just say number of teachers, for example, number of teachers. And this one might be an array of numbers, right? Now let's assume we have a special school. We're creating a special school, so I create a special school, which is of type school, but I only want to pick the students, right? So I'll pick from school, I'll pick only student. So this type will only take in students and it will exclude number of teachers. We can also exclude, right? Or we can take partial. So like getting to a point where you're comfortable with using these different ways of composing data types is what TypeScript is about. And I think you really need to get comfortable with that. Hopefully that answered the question.
Yes, it does. Thank you.
Cool. Right. Then there's the bit of which I think is one of the most important principles, in my opinion. And there's a quote here by one of the authors of TypeScript themselves. Forget the name, but it says making illegal states unrepresentable is about statically proving that the runtime values, all the runtime values without the exception, correspond to valid objects in the business domain. The effect of this technique of eliminating meaningless runtime states is astounding and cannot be overstated. To put it simply, strong typing is about accurately making sure that the states that you're modeling represent what happened at runtime as much as possible. So let's assume, for example, that, and this one I know, given that most of us work with Angular and React, I know some of us might be guilty of this. But let's assume that a request has it can be processed with some numeric message. When we are modeling this sort of state, our intuition would be something like what we have here, which is we have, I'll just call it request for now, and then we'll have in progress, which is a Boolean, we'll have result, which is a number, and then we'll have error, which is a string. The problem with this type here, whether you had it as a type or an interface, the problem is that you're able to represent states illegal or impossible, right? It's possible the value for in progress, it's possible the value for result, and it's possible for you to have the value for, which then begs the question, how are you able to have an error when the state is still in progress? But how are you able to have an error when you have a result? And I know when someone is modeling this, they'll think about, but when I'm getting data from the backend, the backend will feel it, right? And so it will send me a null for error or when there's a result. Yes, that's fine. But then as someone who's reading your code, am I able to reason about your code very quickly and very easily? So here we can also make use of the discriminated unions, right? And a good request or a good representation of that state for a network request would be you have one state which is started or in progress, and then you have another state which is completed, and then it has the result, which is a number, and then you have another state which is error, and then it has an error, which is a string. And we've just seen there that when you receive the request and you're modeling this requested, it's impossible for you to have the state started and have a result at the same time. And it's impossible for you to have the state completed and have an error at the same time. And it's impossible for you to have an error and have either in progress or result at the same time. So it's a representation of how the business logic works. It's a representation of the actual runtime state, right? And it makes a lot more sense when you reason about it. For me, this for me is one of the most important rules or principles to adhere to and keep in mind. But yeah, questions and thoughts. I don't know what silence means, but okay.
Yeah, I
Going
think
once.
Anyone has a question?
At the end of the day, it's supposed to be a discussion, so feel free to say no.
Is it okay to say you've gone too fast on that?
Yeah, we can take it back again. Which aspect that didn't make sense to you?
Just everything.
Okay. So the whole and let me try and write as I explain it. The whole point of static typing is that your types should represent the state at runtime. The reason for this is so that you avoid meaningless or illegal states. And the easiest way for this to make sense is, let's take an example where you want to model what happens when you make a network request. So you're modeling what happens when you make a network request. Are you familiar with Angular or React? Which one makes more sense to you so that we try and use that
Angular.
as an example?
Angular.
Okay, Angular. So in your service, Angular service, right? You've written a function that fetches data from the backend. And in your service, you want your service to also be the one to handle the three states. So three things can happen when you're fetching data from the backend. When you begin the fetch, of course, it will be in progress. and then you either get some result back or there's an error. So let's assume that the result is just getting a number back, and that the error is not complicated, you're just getting a string, which is an error message. So you want to model how the shape of this data when it's coming back. And remember, you want your service to also handle the in progress and catch when there's an error and represent that in your state, so that from a component level, when you're consuming this service, you'll also be able to know whether the service, whether to render that spinner or not. And so you might be tempted, because when you're doing that, well, I forget, but this.http, I guess .get, and you do that generic, there's that observable thing where you say observable of type, I don't know, I think data or something. It's very easy for you to model this data in a way that can represent illegal states. And it might never happen from a code perspective, because the backend will always send you back data, and you'll update as is needed. For example, the backend will never send you an error message if there's an actual result. But you might be tempted to have an interface for data in which you have an in progress, which is a Boolean, so it can either be in progress or true. You have a result, and because you might have a result, or you might not have a result when you have an error, you put it as an optional. And then you have an error, again, because this is not guaranteed to come back, you put this as an optional as well. And this becomes your interface for data. The point I'm trying to make is that this code is not a true representation of what actually happens from a business domain perspective. It doesn't model what happens at runtime, because based on your interface, it's possible for us to have all these values present. If you look at the code, if you're reasoning about the code, it's possible for you to have an in progress value that has a result that has an error. And that's wrong, right? And you might say, well, when the backend is sending me the data, they'll never send a result that has an error. Sure, but if I'm looking at your code, what you're communicating to me is that data can have an in progress, and it can have a result, and it can have an error. So the whole point of eliminating meaningless states is, how do you model your data so that it's a representation of what happens at runtime? And that's where the other example comes in. So in our request state, we have this state which is started, and that represents the in progress state. Then we can also have another state which is completed, and it has the result of number. And you have another state which is error, and it has an error of type string. And when we were working with the discriminated union above, you saw that unless we knew the entity type, if the entity type was an email, there's no way for us to access the name. And if the entity type is of type file, there's no way for us to access the subject. Similar to our request state here, if the entity type is started, then there's no way for us to have an error or a result. And if the entity type is of type result, then there's no way for us to have an error. And if it is of type error, then there's no way for us to have a result. So this here is a discriminated union, right? So our request can either be in progress, it can be, or it can be completed, or it can have an error, but it cannot have all of those things at the same time. And for someone who's looking at this code, it becomes easier for me to reason about and understand exactly what you're representing from a runtime perspective. Did that make sense?
Made sense.
Yes. Is there another question? Cool. Then we'll move on to the other bit, which is avoid immutable objects. And the reason for this is just immutable objects make it way easy for you to reason about your code, and it makes it way easy for you to debug. The problem with changing state, and the concept of avoiding immutable objects is also similar to avoid side effects in a way, because if you have, for example, and just to be clear, when you declare something using a const, it does not make it immutable, right? So if we have, for example, data, and I come and I say data one, I think this is how you access data. Let me just console log it. Yes, if I say data one, and then I assign it the value 3, it's possible for me to change what data is. So data now becomes 3 to 3. The concept of avoiding immutable data is that the fact if you keep on mutating your data, it becomes very difficult for someone to understand where or what changed your data and at what point things went wrong. And so if you're working with data that needs to be mutated, the convention or what is advised is that you copy it. So for example, let's assume we have a function called mutate, which takes in, well, let's even assume data that is defined above. It takes it in and then it changes it. It changes the first parameter. What you're supposed to do, or what is advised for you to do, is you first of all copy. Call this data 2 so that there's no collision. You first of all copy the previous thing, and then you mutate based on the scope that you're in. So here I can come and say is equals to 3 and then return data 2. So you see, I'm still keeping this as it is, so that as someone who's looking at your code, I know that mutate has changed data. And so when I'm looking at where the data might have changed, every function that is mutating data or anything that is mutating data, it's clear that they're mutating data within their own scope. And so I can start narrowing down to those particular functions, as opposed to having every function mutate data how it wants. It makes it difficult for you to track down where exactly, at what point did the data change and what caused that change. So if you look at frameworks like React and Redux, they make this concept fairly obvious. In fact, the whole point, the whole idea around React is immutability, right? Even the way the React updates the DOM tree, a lot of it is based on immutability because it actually copies the DOM, it does some sort of deep comparison, and then it knows what to update. It never, there's always a copy left behind, and if you've done any sort of memory profiling, you'll realize that there's always like a DOM tree that has been cached or something, because React always has, before it updates it, it copies the previous one. In Angular, if you're using the on-push chain detection strategy, you cannot mutate data directly. You would be required to first of all copy that data and then mutate it. Mutate the copied data, not the original data. But you could also work with Redux in Angular itself, and you can also just get used to the habit of copying objects and updating the copies instead of the original. To sort of make this concept obvious, I picked up one of those examples from Angular. So here we have like a component. And what the component does is that when you click on this button, then we call this function change actor. And it takes in the original actor, and then it takes in the details that you're supposed to change from that actor. And if you look at this code does not mutate the object. It doesn't mutate the data, because the original actor that we have is this actor that we've defined in our app component class, and we've given them the name, the last name, and its action, the hero. So the function change actor does is that it first of all copies the original actor, and then it changes only the fields that we want to change. So for example, in our case, we'll change first name and last name, and then we'll never change his action hero. I'm hoping that guys are familiar with the spread operator and how it works. But yes, here we're not, because ideally what we would have done here is just come and say this dot actor and then presented it with like this information here. But then that would mean that we've lost the original actor. And imagine if you're working in a big application and you have so many things that keep on changing actor, it becomes difficult for you to track down and know at what point did actor change, at what point did it become now, right? So always prefer to, as much as possible, avoid mutating objects that are present. Question? Or someone can say mutating data is fine, they don't agree.
Good. Anyone who has a question, feel free to ask.
Okay.
Okay.
Number silence. Cool. The fifth one is prefer pure functions. And I'll begin by saying that because something has the function keyword, it does not mean it's a function. And I know that's a very controversial statement to make. So there's when I say prefer pure functions, I'm looking at it from the lens of functional programming. And so we have to first of all define what exactly is a pure function. So a function must take in a set of inputs, and no input is a valid input. And it has to return an output, and an identified is a valid output. On the very least, every function returns identified, even if you don't have the return keyword. But then there's another caveat, which is for something to qualify as a function, there has to be a semantic relationship between the inputs and the outputs. So let's just look at that quickly. Let's assume we have a function add two numbers. Add. It takes in A and B. And then it returns 40. Right, and then it returns 40. So by our definition, if you look at the definition of what a function is, it has to take a set of inputs. Ours has taken A and B, and it has to return an output, and ours returns 40. But then there is no semantic relationship between the inputs and the outputs. What's the relationship between what we've returned and A and B? So that has to happen. Like there has to be a semantic relationship between the outputs and the inputs in order for something to qualify as a function. So in our case, that would be A plus B. And then comes the question, once we've qualified something as a function, so then what's a pure function? So a pure function is one that has no side effect. Then comes the question, what exactly is a side effect? So side effect is anything that changes the state of a system. A good example of a side effect is, input output operations. So reading through a file, writing things like console log, they actually change the state of the system. Database reads and writes, network calls, those are side effects. But pure functions should not have any side effects. So the function is written there, A and B, it has no side effect. It does nothing to the input output, does nothing to the database, it does nothing to the network calls. The thing with pure function, again, is that they make your code easier to reason about. They make your code very, very easy to test, because the whole idea around testing or writing unit tests for pure function is that you provide it with an input and you expect the output. Pure functions reduce bugs dramatically because they are consistent. You can always rely on them, given the same set of inputs to return the same output or outputs, and they're way easier for you to understand. Now, it's impossible to write code without side effects, because I don't know if you wrote code that didn't have database writes or network calls, whether it would actually work. But when you're writing, and the advice here is prefer pure functions, it doesn't say always write pure functions. So when you're writing code, try as much as possible to move the side effects outside and then remain with the core as a pure function. And this fundamentally is what functional programming is built on. I am hoping that the words make sense, but if they do not, please let me know so that we can actually do an example.
Yeah, I was actually even about to ask if you could do an example on that.
I assumed that it would make sense, and I didn't do any example. So let's assume let's work with Angular, and I'm going to make certain assumptions here. So let's assume we want to make a network request. And then once you've made that network request, we want to shape our data. So maybe there's some data that we want to extract and perform things with. And to keep things simple, I'll say the result of our network request is that it will give us an object that looks kind of like this. The data, it has, I have no idea why I'm obsessed with name, but it has a first name, it has a last name, and it has age, right? And when we want to shape our data, we want to take in first name, last name, and we want to return a concatenation of the two. So we want to return the full name. What would be attempted to do is we'd have a function, let's call it fetch data. And then our function would, let's assume we're working with Angular would do this .http get, we fetch from our service. So maybe it's called what? User.1. We do all those piping stuff we usually do. And then, yeah, it returns, an observable of type full name. Observable that has the first name and the last name concatenated into full name. What I'm saying is extract out, because we can create a pure function whose job is to simply take in the first name and the last name, right? So assuming fetch data, this makes the network call, right? We can extract out another second function compose name, that takes in data, and data has first name, which is a string, and the last name, which is a string. And it returns, let's just, and it returns your full name is first name, that's last name, right? So let's assume like when we do the HTTP, we also manipulate it so that we end up and we return something like this. And I know this is like a contrived example, but stay with me for a while. Instead of you having everything living in this fetch data where you make the call and you shape the data, all I'm saying is extract the shaping of the data outside, because that is a pure function, so that your fetch data, it fetches the result, and then it passes that result to compose name. The beauty of this, and this is a small one, but you typically have like very complex functions. The beauty of this is that we can be 100% sure that compose name works. There's nothing wrong with it. It's easy for us to test. It's easy for us to confirm that if you give it the same first name and last name, it will always return the right thing. And we can extract that impurity outside. so that if there is a bug in our fetch data, we will not blame compose name because we know for a fact, given how pure compose name is, it has no bugs. It works how it is expected, unless you have a logical bug, but it works how it is supposed to work. And therefore, we know that whatever error there is with fetch data, it has to be when we are making that API call. Did that make sense, Wayne?
100%. Thank you.
Yes. Yes. So as much as possible, extract out the impurity, have the pure function live by itself, so that you're reducing the surface area for potential areas of bugs. Because with pure functions, unless you made some sort of logical error, most of the time you can be sure that they're reliable and they work as expected. Cool.
Just a quick one.
Yes.
Yeah, just on the same. Could you liken that to, for example, how you would have sorry guys, I'm in terms of Angular, where you create a service and then you have like this function, let's say, I don't know, get users, right? And then you're just returning the observable of type users, for example, and you call on that service, that method that's in that service, for example, in a component, and then you can pass in the data. Is that something similar to that?
Yes. So you see the function you have, the actual term for it is a procedure, given it has a side effect, but let's just call it function. So the function you have in a service that gets the data from the API and returns the observable, right? That's the function that has side effects, right? Now let's assume you want to do some sort of manipulation with that data, and let's assume that manipulation lives in the component, right? Then have a function in the component, or you can still even have it in the service itself. But whatever you have, wherever you have it, just make sure that all it does is take in an input, right? And it performs whatever operations you want and returns that output. And it doesn't care where that input comes from. Am I making sense?
Okay.
And let me try to think of a better one in Angular. I'm trying to really avoid thinking in React. let me think of a good example in Angular. Yes. Let's assume, right, Wayne, you get an API call, right? And the API call returns you some sort of date. And you know the date that we have in our backend, it's a weird ISO date, ISO formatted date, right? And this is not what we want in fact, I've just gotten the best example of a pure function, but we'll go ahead. And this is not what you want on the front end. This is not what you want to display to the user. So you want to format this weird ISO date so that it's 16th June 2022, right? You see that pipe that you have that formats the date?
Yeah.
That's a pure function because it doesn't care where that data comes from. It has no idea that that data has been fetched from the backend. You could pass it that data statically, and it will still format it, right? So if your date is not being formatted correctly, you cannot blame that pipe. Likely, it's an issue with your API because the pipe formats whatever you give it correctly.
Okay. That makes sense.
Yes.
Thank you.
Cool. All right. Then we move on to point number 6, which is avoid module state. So before we begin, the first question I would ask is everybody familiar with what a module is? Otherwise, I was making the assumption that we are familiar with modules.
We just like
there's somebody
who just like do like a basic explanation.
So a module is a file. That's it. A module is a file. So like learning TS is a module, right? That's the most basic explanation. So the recent JavaScripts that we have, ES6, every file is treated as a module. So you've seen things like export function, add number, and then you go in another file and then you do import, add number from learning.ts, right? So then learning.ts is a module, simply a file. So if we have a file, it's very controversial to tell someone to avoid module state. And before we even look at the example, I'll say this. The function of a module is to present code, not to handle state. Right? The function of learning TS when you're exporting stuff is so that, and I'm talking about especially when you have, because I know we use frameworks and frameworks are a bit more complicated. I'm talking about when you have like a lean file where you have a file that is supposed to be like a utility file, for example. As much as possible, let it just export function and code that will be used, and it should, as much as possible, avoid being stateful. So module state occurs when you declare variables in the outermost scope of your module or file. So this is outside of all functions and classes. So an example is we have this locale here, and it is of type string, and it's the first value is English US. And then you have this function set locale, which takes in a locale, and then it returns. It sets the locale. It sets the current locale to whatever locale you provided it. Then you have another function called get localized string, and if the locale is English, it just returns hello world. Otherwise, if it's anything else, it just returns Greek. So the issue with module state, and you can see here, locale, current locale is module state. And I say it's module state because it can be changed within the file. Something in this file can actually change it. Maybe somewhere down along the line, someone can declare another variable called current state, current locale, or even use the same one and set it to something else. That in itself starts making current locale behave statefully. So the presence of module state implies side effects across function calls. And then the module starts behaving as a stateful object with methods, right? So it stops behaving like an actual module, which is supposed to just export code, and it starts behaving like a stateful object that has methods. And module state being stateful is not bad, as long as you can rely that there's only one of those modules. So you can rely that it's a singleton. Because the reason with having stateful modules is that you can end up with something called duplication when you're bundling using things like Webpack. A good example is npm doppelgangers. And you have to take a lot of care when you're having states in modules, where you have side effects in your modules also make it harder to perform tree shaking, because you need to explicitly tell bundling tools like Webpack which modules have side effects, which modules have state, and you do this in your package.json. There's another field called side effect where you now declare if that particular module has a side effect or it doesn't. So imports should only be used to access code, not state, right? And a caveat here is that module state is not a module constant, and module constants are fine. And a module constant is just a variable that does not change, right? So the whole idea of state is that it's able to be changed. But if you have one that cannot be changed, then you should be good. I know that was a bit intimidating, so I'm actually hoping for questions there.
Yes, I have a question. So
Go ahead.
I'll look at it in a React way. So most of the time when we are declaring the states in React, we declare it using like const this and this is equals to that. So what you're saying is that I should preferably use or rather declare the states using const instead of using lets. Or
okay, so no. So so let's start with again. So this is not. So I'll just it's usually export default app component, right? Export default function, something like this. right? And then maybe text and props. Shoot me. Most of the time when you're declaring state, you'll do something like I don't know, counter. Set counter.
Those states.
And then you do react.useState.
Yeah.
And then maybe you give it a 0. So this is not a module state.
Right. Okay.
Right.
Yeah.
Let me tell you now what a module state is. Now let's assume we didn't have this, right? And you decided, because React will handle for you this state. And remember, React by its core prefers immutability, and it has mechanisms to ensure that this is not a module state. Let's assume you're not very good in React and you're kind of new to React, and the whole concept of state is bothering you. So you decide to say let counter, right? And you initialize it to 0 here, right? And maybe there's a button, an on-click function there. To const on click, and every time the button is clicked, you say counter ++, right? Because if you were to use the React use state, you won't be able to do this, right?
Yeah.
But with with a module state, you can. Let me just do number. Right. You can say counter is equals to counter or counter +1, whatever. So this officially makes this a module state, right? Because it's been declared above every other function, every function and class, right? And if you are to come back to JavaScript as a language, right, then variables in most of the time, in most cases, variables are scoped, right? And variables can be scoped in a number of ways, right? It can be scoped to the block if you're using something like const and let. Yes.
Yeah.
It can be scoped to the function, right? If you're using something like var, right? It can be scoped to the global object if you, again, using something like var, and it can be scoped to the module, right? So this variable counter here, it has to be scoped somewhere, but you see, it does not live within a function. It does not live within a class, and a class is just a function. It does not live within a block. It's hanging, meaning the scope has to be handled by the learning.ts file, right? Which officially makes it a module state. So that's a module state, not when you say const counter here, down here, set counter. So this is not a module state. This is what becomes a module state. Something I wanted to say. Yes. So one of the things in React that actually does use a module state, and you should be very careful when you're using it, is the React context. Right? So when you have export function app component, and if you're not in React, I apologize. And then you do something like let's assume counter, and then you do React dot create ref, right? Create context, I mean, and then you continue and stuff like that. This counter here, right? It actually gets scoped to the file.
Right.
It gets scoped to that module. Now, when it gets scoped to the module and you're bundling, right? You need to wonder how it's possible for Webpack to know that when you go to another component, like, I don't know, login component, as long as it is wrapped with that counter provider, and then you provide it with the value and you say it's the counter context, right? It must have occurred to you at one point, or you must have been curious, how exactly does the other component know the value of the context I created? Right? Because the bundler is able to present that module state to other modules, right? Because then it no longer behaves just like a module would, which is presenting code. It now behaves like a stateful object, right? Meaning as long as it has been imported by another module, that module is able to access that state, right? And in fact, React is the biggest culprit of this module state stuff, because even when you're using context, and I've seen this personally, when you're using context, it's more often than not, and you will be surprised, you end up with two contexts being created. So assuming you had a counter context, you end up with two of them. And this is true, especially if you're working in like a mono repo and you have like overriding being done by Webpack. When you end up with two similar or a duplication of the module state, suddenly your app starts to crash. Because according to Webpack, those it's like choose one. I cannot have two module states with the same name. And your app just starts crashing. And sometimes it's a pain to debug and figure out, okay, it's because of that context that we created. So, because if you don't tell Webpack that that particular file is going to have some sort of module state, Webpack does not know how to bundle it. And so it will just bundle it how it thinks it should. And there's a very high chance of you ending up with like two of the same module states, and it is one of the most painful things to try and debug. I kid you not.
Okay. All right, cool. Thanks.
Yeah, but I'm hoping that answered the question.
It did.
Cool. But yes, it's very possible for you to declare constant at the root of the module. It's easier because constants can't be reinitialized. And so it's easier. You might still end up with the same sort of bugs, but it's easier for you to figure that out because it will just scream that you reinitialize something that you're not supposed to.
Yeah, okay.
Yes. Then number 7, again, I didn't add an example, but this one is just should be self-explanatory. So as much as possible, not always, but global variables should be avoided. Avoid adding stuff to the window, and I've been guilty of using window.set timeout. Just use set timeout. Do not add it to the window. Avoid adding stuff to the global because it has a lot of effects. The biggest one being namespace collision. So, for example, you might add something to the window. Maybe we add window.counter. And then a library that you've imported also has the same window.counter. So we end up with like this namespace collision where either A, you might override the value that they have for the library, or the library might override the value that they have for you. And so you don't know why your code is not working or why the library's code is not working. That's what namespace collision is. On the window object, you end up having two variables that have the same name, and one has to, I guess, override the other. But the biggest thing for me is just the possible side effects. Again, side effects are not entirely bad, but use them sparingly. And some of those stuff might not be accessible. So if you're somebody who likes to use service workers which run on the worker thread, and you are doing something on the window object, then window is not accessible in the worker thread. Or for example, if you're doing something in the global object, and then you go to React Native from React, then the global object is not accessible. In fact, the window object is also not accessible in React Native. So just as much as possible, make sure that your code does not rely on these global variables. Yeah, I don't know if that needs an example, but I'll stop there first.
All good, all good. Anyone else has a question?
Cool.
I think all good. Let's move on.
Great. Number 8 is a general programming principle, especially in OOP. Program through an interface, not an implementation. And I think for this one, you'll actually have to do like a contrived example. But the concept of it boils down to this whole idea of solid principle. and especially the O principle, which I think is open for modification and closed for something. Basically, can your code be decoupled from any particular implementation? How easy is it for you to actually make changes to your code without necessarily breaking so many things, right? And the best way for you to do that is to ensure that one module of your code is not directly dependent or connected to another module of your code. Now I know that the whole statement sounds a bit weird, but this is what it means. Let us assume we have two things. We have a class called student, and that class has a name. Again, I don't know why I don't know what's with me a name. Why is it complaining? Please. And then age, you'll have to forgive me. Then you have like get student name. And it returns what? Like how it returns. Let's just call it get student. And what does it have? To return for you the student name and the student age. And then you have a class called school. And within school, you can say student, I guess. And you initialize new student and supply to the name, maybe Henry, the age 16. And then you do something with that. Okay, it's supposed to be a number. Come on, shoot me. Right, and then here you do something with student. This is what is called programming through an implementation, right? Because the class student is an actual implementation, and school relies on the implementation of student to do something with it. So this is bad, right? Because if any changes were made to student, or if you wanted to change something about student in school, you'd have to go back and change something about the student class. And if any changes are made to the student class, then definitely it's going to affect the class school. Instead, what you should prefer is, have an interface. So I'll call it iSchool just so it's different from school. Interface. Suppose it has a name, which is also a string. It has an age, which is a number, and then it has a method getStudent. And the method takes in the name, which is a string. The age, I think I can just provide it like name and age. It won't complain. Okay, need to provide the types. String, number, and we can see from there it returns as a string. So in school, relying on a student, let it rely on program through an interface. So then it implements iSchool. I like, and here you'll be required to implement those methods, right? And you can now go ahead and do something with student the way you want it to happen. This is a much more flexible way of coding, and I'm not sure why it's complaining, but I need to initialize them. But anyway, this is a much more flexible way to code because you can change how student is shaped or how it works without necessarily changing the interface. And it's also possible for you to sort of extend the interface without necessarily affecting other parts of the code. So let's assume that other parts of the code also rely on iSchool, but then you have a special school. And the special school maybe has foreign students, right? Special school. And we want to add that, we want to extend that functionality so that we also have country. So we can just extend the interface iSchool, extends iSchool, and then here we can add country, maybe it's a string as well. And then instead of this implementing iSchool, we can now make it implement special school and continue building on top of it so that we never affect the code that relies on the implementation of iSchool, and we get the benefits of still relying on iSchool and extending it. This is way better than programming through an actual implementation. And I'm hoping to have questions here, especially from the Angular guys. So things like ng on init, those ones are implementations. They are not implementations, they're interfaces. And you can see when you extend them or when you implement them, you're typically asked to implement the method. What you do with that method, they don't care, because an interface doesn't care what getStudent does as long as it takes in a name and an age and it returns a string. So Angular relies heavily on this concept of programming through an interface and not an implementation. In fact, as a framework, I don't even think Angular can allow you to. It can, but yeah, you have to be really a special breed for you to get to a point where you're programming through an implementation. But however, I have seen people define classes and then go and instantiate those classes within components. And no, that is, don't do that. Let's just say don't do that at all.
Yeah, I think I personally agree with that. But I think, of course, different companies will tell you like different how they want to do this. But I personally prefer using interfaces. I don't know, for some reason, it looks more modern than using the typical class and all that. Yeah, so I don't know, that's just an opinion. I don't know, for me, I think probably I had like this negative experience with Java. So whenever I see class, student, whatever, I get triggered. So seeing interface, I don't know, for some reason it's just more beautiful than using classes. So, yeah.
See classes. But at least you get the benefit, yes. So yeah, when you see yourself within a class, having to instantiate a new class, it's probably best to rethink the approach you're taking. Yeah, because especially if that class that you're instantiating has been instantiated in multiple other classes, it becomes very difficult for you to extend the capabilities of what that class can do without going and refactoring code for all the other classes that rely on the same implementation. Cool. Hoping that one was clear. Right. Then there's number 9, which is leverage on structural equivalence. So in TypeScript, variables are assignable to each other if they are structurally equivalent. So it doesn't matter if a class implements an interface or not. In fact, a case can be made here that an interface belongs to the user, and any function can declare exactly what it needs. So for example, a function does not need to care about the entire interface, right? A function can pick out just what it needs from that interface. And using our example from above, from before, where we had the type, the entity types here, where we have entity type email, entity type file, and entity type person. So you can see file and person both have names, and we want to create a function here that returns hello and then the name that you provided it, and the function takes in an entity. Instead of you coming and saying entity is of type, so let me just copy this so that it makes more sense. Instead of you coming and saying entity is of type file, right? You can make the function a bit more generic in a way, or open, so that it doesn't care whether it's a file or a person. As long as the entity that you're providing it has a name, it will accept it. And that's pretty much what we're saying here. Like, especially when you're working with functions, rely on variables that have structural equivalence, so that you extend your function and you give it a bit more flexibility. So the say hello in this case would work with both files and person, without needing to mention exactly or explicitly which type they want, because both of those types have the property name. And then there's one thing you might have noticed here, which is the read-only modifier. This could go into another point on its own, but again, it goes into understanding TypeScript at the core, because the modifier guarantees that no mutation will happen, and that the only thing the function is going to do with that object is read it. And so it makes you declare your intent very specifically. And using it this way, it means that we can rely on the function to safely use the data without it ever being mutated within that function. And if you try to, and this is something else TypeScript will do, if you try to, for example, mutate name, maybe change it to something else or add something to it, TypeScript will actually start screaming. So yeah, also get used to modifiers like read-only, especially when you only want that data to be read. In React, this is beautiful. When you're prop drilling and you only need, you have like a DAM component, and the only thing that DAM component is supposed to do is represent that data and display it. It's not supposed to in any way mutate it. Then when you're declaring the interface for that prop, you can have the interface have the modifier read only. That way, if at any point in your code someone else came and they were trying to do something with that data, then TypeScript is going to give them a compile error and say, you can't do that with this particular property. This is only a read-only property. Is there a question there? Okay. Then go to the final one, which is the most important one. So understand the relationship between TypeScript and JavaScript. TypeScript does powerful type checking, but those types mostly disappear when you transpile from TypeScript to JavaScript. And here's a fun fact, and this might go to, again, one of the benefits of you using interfaces over classes way. So classes are enums. They still retain their identities at runtime. In fact, enums in TypeScript, unless you declare them using the const keyword, they'll still be there even at runtime. So yes, most of the time when you're bundling code and you're shipping to customers, it's going to be JavaScript code. So really, you want to understand what the end result looks like when it's running on the browser, how to debug it, how to profile it, and how to hack it. And a good example is when you're trying to understand performance issue in the browser. You should probably go back to the first principle and look at how your JavaScript code actually behaves in the browser, instead of trying to reason about it through the lens of the abstraction that is the TypeScript source code. So when things get to the browser, they're JavaScript. So do not think about them as TypeScript. So it's important for you to get the relationship. The beauty and the power of TypeScript is that all those type definitions, by the time they get to the browser, they disappear. So you want to keep that in mind, because sometimes I've seen people struggle. You're trying to look at the browser and debug your code, and you're debugging in the lens of TypeScript, and it's like, but now you're in the JavaScript world, and those two are entirely different programming languages. So yeah, understand that relationship and get it right from the first principle. Yes, that was it. A lot of boring stuff, but I think, yeah, if you want to get better at programming beyond just code works, I think it's important to develop the right sort of principles and guidelines. And I'm hoping that some of these could make you think better about the kind of code that you write. They certainly have made a difference for me. There's a lot more than this, but for me, these 10 are the most interesting, I guess. Yes, and I am done. Sijui hata kama nimekula time ya watu. Hey, yes.
I think we're within the limit that we say that we'll be doing. That was an hour and a half. That's
Okay.
typically what we usually do for this session. And I think I like the last part, which is understanding. It's like understanding JavaScript first before when you're writing a TypeScript code. Because if you understand the basics, it's much easier for you to like debug and all that. So that's super helpful and super insightful. Yeah. I don't know if anyone has questions or comments or suggestions. Please feel free to unmute yourself and ask.
Guys, I'm going to sleep. I didn't even know what time it was.
Hi.
Yes.
So I'd just like to say that it's been an engaging session. It was not boring. I mean, I was just here writing notes like most of the time. So I hope you'll share the markdown. And
Oh, yeah,
yes,
I can. Yeah.
and I
I
have
can share
many.
it with
And I think if questions come up, I think you will be reachable. If you could please provide your LinkedIn and Twitter.
I'm in the Angular Kenya community.
Oh,
Are you in
okay.
the group? Are you in the group?
Yes, I am.
Yes, there's someone who goes by the name Drew. Do not ask the relationship between Henry and Drew, but the Drew is me.
Okay, no problem.
Yes.
Otherwise, thank you so much. I wish you could go on.
Yeah, no, in that. Yeah. Maybe next time we can discuss
Anyone else
more about functional programming and what pure functions mean.
Yeah, I think we can definitely schedule another discussion, probably for the next meeting. And we can definitely have this kind of discussions. Doesn't have to be necessarily Angular based. It could be even just coding practices like what we did today. So yeah, we can definitely have something like this again.
Cool.
And next time it will be a conversation.
Yeah, good.
Yeah.
We'd also like to have people like sharing experiences. Like what kind of coding practices do they implement their day-to-day activities. So yeah, I think that's pretty amazing. Thank you once again, Henry. We appreciate it. And by the way, this session was held by Angular Kenya. So if you are interested, just learning about Angular, feel free to reach out Angular Kenya on Twitter, or you can reach out to me when you're on Twitter, and we can definitely give you contacts on how you can join, or you can also follow Joy Leader also on Twitter, and should be able to then like direct you. So without much further ado, I'd like to bring this session to a close and like to give you, I would like to say a big thank you to all of you. Just probably closing remarks, Henry. Any closing remarks?
Yes, do not get too hung up on frameworks. Understand the languages.
Sorry?
Very, very soon.
I say don't get hung up on frameworks. Just focus on the languages.
I think that's a very strong point, for sure. Yeah, thank you. I think you've had that joy, right?
Yes, I have. A challenge to me.
Okay. All right then. Yeah, wishing you all a good evening, and you'll get the recording. It's gonna be up by tomorrow afternoon on the Angular Kenya YouTube channel. So feel free to also check out some of the content that we have over there. And yeah, have a good night, everyone. Bye.